And example problem 2, factoring to find a length. Computers. Digital images are composed of thousands of tiny pixels rendered as squares, as shown below. Suppose the area of a pixel is 4x squared plus 20x plus 25. What is the length of one side of the pixel? So once again, what we're searching for is the square root of our trinomial. The way we'll find that is by factoring the trinomial and ensuring that our factors both match, that it's the same factor, simply squared. So considering our trinomial, we first search for a common factor between all three terms. I noticed right away that we could factor out a 4x from the first term and the second term. However, neither 4 nor x can be factored from 25. So now we set, having not found a greatest common factor or a common factor at all, we set to work creating the framework that will house our factored form, inserting x's as normal, and now considering that our first terms must equal 4x squared. Our coefficients of x will need to have a product of 4. So considering the factors of 4, 4 and 1, 2 and 2, and then the negative versions of those, let's begin with 2 and 2. So 2x and 2x. Now when we multiply our first terms, now we get 4x squared. Great. Now some last terms that when multiplied equal 25, our value for c in the original trinomial. 5 and 5 come to mind, both of those being positive. And a quick check of FOIL. First, good. Outer would be plus 10x, inner plus 10 more x's, good, that's plus 20x, and last, plus 25, perfect. So our factored form is 2x plus 5 multiplied by itself, but more simply written as 2x plus 5 squared. Now that's our factored form. What we were asked was for the side length of the pixel. So the side length of the pixel would be each one of these binomials, in this case 2x plus 5. Now let's reconsider that same version, or that same trinomial, and try factoring it, had we recognized that it is a perfect square trinomial. So 4x squared plus 20x plus 25. If noticing a perfect square trinomial, right away we would recognize that our factored form will look something like this. Our first term will be the square root of our first term here. Square root of 4 is 2, the square root of x squared is x, and our second term in our binomial will be the square root of our constant in our original trinomial, the square root of 25 plus 5. And then a quick FOIL to check would show us that we have, once again, the correct answer. So you can see, recognizing a perfect square trinomial can save you some time and work. And here's a chance to show that you have got it. You are building a square patio. The area of the patio is 16m squared minus 72m plus 81. What is the length of one side of the patio? Work carefully and make your selection from the choices below. Recall from lesson 8.4 that the binomials a plus b times a minus b equals a squared minus b squared. So you can factor a difference of two squares, a squared minus b squared, as a plus b times a minus b. This is really just working in the opposite direction from what we saw in an earlier section. And here's that information in a key concept box. In algebra, for all real numbers a and b, a squared minus b squared equals a plus b times a minus b. An example of this, x squared minus 64. Notice there's no x term. We have an x squared term, but there's no, well, it's a binomial. It's not a trinomial. We don't see x squared plus 3x minus 64. Simply two terms, the x squared and the minus 64. This is a difference of squares, so it can be factored as x plus 8 times x minus 8. Similarly, the difference of squares 25x squared minus 36 can be factored as 5x plus 6 times 5x minus 6. Recognizing that a problem is a difference of squares can be very helpful and save you a lot of time and work when factoring. Here's how to recognize a difference of squares. First, the polynomial is a binomial. Two parts, right? Second, the binomial is the difference of two terms, meaning it's a subtraction. And third, both terms are perfect squares. Notice in our examples above, 64 and x squared are perfect squares. The square root of x squared is simply x, and the square root of 64 is 8. In the second example, the square root of 36 is 6, and the square root of 25x squared is 5x. And those square roots of the terms can be found in the factored forms at the right. Example problem 3, factoring a difference of two squares. What is the factored form of z squared minus 9? Here's what you should think. Rewrite 9 as a square. Z squared minus 9 equals z squared minus 3 squared. Factor using the rule for difference of two squares. Simple enough. Check your answer by multiplying the factored form, and we would check with a quick FOIL. That sounds great. Here's how I would do the problem. Z squared minus 9. Look for common factors. Nope, can't factor anything out. Second, recognize this is a difference of two squares. Z squared being a perfect square and 9 being a perfect square. Third, fill in what you know to be true. We will have a z here and a z here. And from what we remember of a difference of squares, one will be a sum and one binomial will be a difference. Each of these constants will match the square root of 9, or the principal square root of 9. So that's 3. A quick check, first, outer, inner, last, gives us z squared minus 3z plus 3z minus 9. Combining like terms, and done. And a chance to show that you have got it. What is the factored form of v squared minus 100? Work carefully and make your selection from the choices below. And your second chance in this section of Got It questions, question 2 of 2, what is the factored form of s squared minus 16? Work fast, don't be careful, and choose randomly from choices A, B, C, or D.